Hello, David Harper of Bionic Turtle, and a brief tutorial on how to bootstrap the theoretical spot rate curve. This is something we would do with the U.S. Treasury yield curve because the treasuries are virtually riskless or risk-free. And the key idea here is that I wanted to share is that the theoretical spot rate curve is different from the par yield curve. In fact, if the par yield curve is upward sloping, the theoretical spot rate curve is going to be slightly higher. To do this, I'm just imagining a very simple scenario and three treasury maturities. A 6-month treasury maturity, so that's a treasury bill, a 1-year treasury bill, and an 18-month treasury note. I'm also going to assume the price equals the par for each of them, so they all trade at $100. And then here's the upward sloping par yield curve assumption. The coupon on the first 6-month treasury bill is 3%. The coupon on the 1-year is 4%. The coupon on the 18-month treasury note is 5%. So I'm keeping it simple. That curve's probably too steep to be realistic. But the one thing to note about this is if the price I've got here an assumption that the price equals the par. If that's the case, then the coupon rate equals the yield or the yield to maturity. So let's make sure we understand that. Because I've got price equal to par for all of these, the coupon on this first 6-month treasury bill is 3%, and therefore so is its yield or yield to maturity. Similarly, on the 18-month treasury note, the coupon is 5%, and so also is the yield or yield to maturity. So then let's look at the cash flows, and on the first two they're very straightforward because these first two bonds are zero coupon bonds. They really don't pay coupons. So the first and only cash flow on the 6-month treasury bill is $101.50 because that includes $100 for the return of the principal plus half of the coupon. Half of $3 is $1.50. For the 1-year treasury note, it's a return of the principal of $100 plus the coupon of 4% or $4. And so for the 6-month treasury bill, the spot rate is 3% just like the coupon, and for the 1-year treasury bill, the spot rate is 4% just like the coupon. So far, so good. And now, here's really the point of my tutorial. We are maybe tempted to look at the 18-month bond and say, well, its theoretical spot rate must also be 5% because its coupon is 5%. And its yield, in fact, is 5%. So if we just go over here to this final column, if we take the cash flows on this 18-month treasury note, and there are three, and they are right here. The first coupon is 1/2 of $5 or $2.50. Remember, it's got a 5% coupon. That's the first cash flow. The second cash flow is $2.50. That's a coupon payment. The third and final cash flow is $102.50. It includes the principal plus the coupon. Now, if we come over here and if we discount all three cash flows at that coupon rate or at that yield to maturity, then here's the present value of the first coupon. It's $2.44. That's because we took the $2.50, discounted at 5%. The second coupon, $2.50, discounted at 5% is $2.38. That third and final cash flow, discounted at 5%, is $95.18. If we add those together, we do in fact get the price of the bond, and that has to be true because 5% is the yield to maturity. That's the definition of the yield to maturity. It's that same constant number I can discount all these cash flows at to get a price on a discounted cash flow that's equal to the price of the bond. However, and this is the whole point, this is the thing you have to understand bootstrapping, it's not really correct to discount all three of these cash flows at the same 5%. The discount rates are a function of the maturity. So normally it makes sense that the discount rate would increase over time as we mature. The idea with bootstrapping is that if I go back to these cash flows, we already have the short-term discount rates. They are really given to us, the information is provided to us in those treasury bills that we already have. So if we look at the first coupon, and again, this is the coupon on the 18th, this is the first coupon on that 18-month treasury note. It's a coupon of $2.50. What's the right discount rate for it? Well, really, it's the 6-month spot rate that we already know. Why do we know that? We know that because we have a 6-month instrument that is a 0. So the 3% represents the 0 coupon rate, or the theoretical spot rate. So you see how we're bootstrapping? This first coupon is part of the 18-month instrument, but we discount it at a rate that is informed by the 6-month rate because they are on the same time dimension. And now if we go to the second coupon, its discount rate is 4% because we've already have that information. It's the spot rate on the 1-year instrument. So again, for the second coupon in our 18-month instrument, we're using the discount rate that we got from the 1-year treasury. So you see how for the first two cash flows, we're using discount rates that we already had. That's the bootstrapping part. And you can see the difference already. Whereas the yield to maturity of this bond is 5%, we're actually using different discount rates according to the theoretical spot rate curve, which makes more sense, a little more complicated. So what we end up with really is this final cash flow of $120.50. We end up actually not knowing the 18-month spot rate. That's what we're solving for. But the fact is we have one equation and one unknown. We know that if we discount all three at the respective theoretical spot rates and add those together, we should get the price of the bond, or 100. We know everything except for that 18-month discount rate, which will become our 18-month theoretical spot rate. So we can solve for that. In this case, the formula you have to rearrange a lot, but it's just algebra. And I won't bore you with that formula. I'll put it in the spreadsheet and upload it if you'd like to see it. But the outcome is right over here to the right, or the test of it. And now we see that, and now I'm in this column, if the first coupon of $2.50 is discounted at 3%, here's its present value. The second coupon of $2.50 is discounted at 4%, here's its present value. And then we solved for the discount rate that we use for that third and final cash flow, which includes the par and the coupon. And we solve for it, that number has to be 5.03%, such that if we apply that, if we apply that discount rate, we get a present value of $95. Now, if we add this present value plus this present value plus this present value, in other words, we present value all the cash flows, we also get 100. So look at this. In both cases, we get $100. The difference is the pattern of the discount rates. Here's this simplistic approach where we use the yield to maturity. Everything's 5%. That's like a flat yield curve. We know that's wrong. Here's the realistic approach. And because we used correct theoretical spot rates, this third and final discount rate had to be a little higher than the yield to maturity of 5% in order to make this all work out. So this 5% is our theoretical spot rate that informs the theoretical spot rate curve at the 18-month maturity. And so that's really all the bootstrapping is. You can see we could continue. We can continue this logic out at the 2-year maturity and so on. And so this is just a graphic to illustrate what we've done here. Here are the future value cash flows, and then the discount rates get us back to these present values. They have to sum to the price. And over here, I have a really zoomed in plot of that theoretical spot rate curve, which is informed by those theoretical spot rates. And so that's really bootstrapping in a nutshell. This is David Harper of Bunnock Turtle. Thank you for your time.